Hello everyone and welcome to Fun Maths, where we make maths simple and fun. Today, we're diving into laws of indices, a super important topic in algebra that makes working with power much easier. Whether you're a student preparing for exams or just brushing up your math skills, this video is for you. Let's get started. First, what is indices? Indices, also called exponents, is the plural form of the word index. It shows how many times a number is multiplied by itself. It is always in the form a raised to the power n, where a is the base and n is the power. For example, 2 raised to the power 3 just simply means 2 multiplied by 2 multiplied by 2, that is 2 in 3 places, which is equal to 8. Now let's break down the laws one by one. Law 1, the product law. When multiplying numbers with the same base, add the power. That is, if I have a number that has the same base or two numbers that have the same base, a and a, all I just have to do is to add up the power. For example, if I have 7 raised to the power 6 multiplied by 7 raised to the power 4, because the both of them have the same base, which is 7, I'll pick one of the base, then I will add up the power. So therefore, I'll have 7 raised to the power of 10. That's just that. Another example, the both of them have the same base, which is e. So I'll pick one of the base, then I will add up the power 4 plus 3. And that's just simply e raised to the power 7. Let's go to law 2, the quotient law. When dividing numbers with the same base, subtract the power. That is, a and a are the same base, and I want to divide them. All I have to do is just to subtract the power. For example, if I have 8 raised to the power 5 divided by 8 raised to the power 2, because the both of them have the same base, I will just pick one of the base, then I will subtract the power. So I will simply have 8 raised to the power 3. Another example, e raised to the power 8 divided by e raised to the power 5. Both of them have the same base, e and e, and I'm dividing them, so I'll pick one of the power, one of the base, then I would subtract the power. All I have is e raised to the power 3. Let's go into law 3, the power of a power. When raising a power to another power, multiply the exponents, that is, multiply the powers. That if I have a raised to the power m raised to the power n, so I'm raising this power to another power. All I just have to do is to multiply the powers. For example, 6 raised to the power 4 raised to the power 2 will simply be equal to 6 raised to the power 4 times 2, which is equal to 6 raised to the power 8. Another example, e raised to the power x raised to the power y will simply be equal to e raised to the power x times y, which is equal to e raised to the power xy. Okay, let's go into law 4, the zero exponent law. Any number raised to the power of 0 is always 1. That is, a raised to the power 0 will always be equal to 1. So no matter what the number is, as long as it's raised to the power of 0, it will be equal to 1. For example, 7 raised to the power 0 is simply equal to 1. Another example, x raised to the power 0 will also be equal to 1. Let's go into law 5, the power of a product. When raising a product to a power, raise each factor to that power. For example, that is, if I have ab raised to the power n, so I have two values raised to the power n, it will be a raised to the power n multiplied by b raised to the power n. Examples, if I have 2x raised to the power 3, this just equal to 2 raised to the power 3 multiplied by x raised to the power 3, which is 2 raised to the power 3 is 2 times 2 times 2, and that's 8, multiplied by x raised to the power 3. So my final value is 8x raised to power 3. And that's it. Another example, if I have 3y raised to power 4, that would just simply be 3 raised to power 4 multiplied by y raised to power 4. 3 raised to power 4 is simply 3 times 3 times 3 times 3 times 3. Then times y raised to power 4. 3 times 3 times 3 times 3 will simply be 81 times y raised to power 4, which is equal to 81y raised to power 4. And that's the solution to that question. Let's go to law 6, power of a quotient. When raising a quotient to a power, raise both numerator and denominator to that power. So if I have a fraction, for example, a over b, raising to a power n, just raise the numerator to that same n and the denominator to the same n. For example, if I have 2 over 5 raised to power 2, this will just simply be equal to 2 raised to power 2 divided by 5 raised to power 2. That is, 2 raised to power 2 is 4, 5 raised to power 2 is 25. So 4 over 25. Another example, if I have x over y raised to power 4, this will simply be x raised to power 4 over y raised to power 4. And that's the solution to that question. Law 7, negative exponents. A negative exponent means the reciprocal of the base raised to the positive exponent. That is, if I have a base and I have an exponent that is negative, in this case minus n, all I have to do is to find the reciprocal of that base. The reciprocal for a is 1 over a. Then the exponent changes into positive. Please note that if I have a whole number, the reciprocal of that whole number is just 1 over that whole number. But when I have a fraction, for example, 2 over 3, the reciprocal of this fraction is simply 3 over 2. That's what reciprocal is. Let's take some examples. 3 raised to power negative 2. What is the reciprocal for 3? It's basically 1 over 3 raised to power the positive of the exponent. Now, remember the rule that says if I have a fraction and I have a power, the power is for both the numerator, in this case 1 raised to power 2, over and also the denominator 3 raised to power 2. So 1 raised to power 2 just simply means 1 multiplied by 1, and that's 1, over 3 raised to power 2 is simply 9. Let's take another example. X raised to power negative 4. This basically is 1 over x raised to power the positive, because the reciprocal for x is 1 over x. Now, 1 raised to power 4. Now we have 1 raised to power 4 over x raised to power 4. 1 raised to power 4 just simply means multiplying 1 4 times, and that's 1 over x raised to power 4. And that's the solution to that question. Law 8, fractional exponents. Fractional exponents represent roots. That is, if I have a fraction as my exponent, in this case 1 over n, it is just the nth root of the base, which is a. Take note, if I have 1 as a numerator, it is just the nth root of a. But if I have a fraction n over n, that is, I have a fraction that is not 1 over n, but a value over another value, the numerator of that exponent becomes the power, while the denominator becomes the root. In this case, the denominator is the nth root of a raised to the power of n. Let's take an example. If I have 16 raised to the power of 1 over 4, that's just basically is the fourth root of 16. Now, because I have a numerator of 1, the raised to power 1 is not significant, so I don't need to include it. Now, what is the fourth root of 16? That is, what is that number that if I multiply it 4 times, it will give me 16? That's just basically 2. So the fourth root of 16 is 2. That's the solution to that question. Another example. Now, in this case, I have 27 as the base, and I have an exponent of 2 over 3. Now, the denominator of my exponent becomes the root of the base, which is 27, raised to the power of the numerator. So now what is that number that if I multiply 3 times it will give me 27? That's just 3. Don't forget the power 2. So 3 raised to the power 2 will simply be equal to 9. Now we are going to dive into questions that require us to apply different laws. Let's start with an example. If I have 2 raised to the power 5 multiplied by 4 raised to the power 3 over 8 raised to the power 2, how do I simplify this question? Firstly, my numerator cannot be multiplied because I have different base. But I can simplify one of the base such that a raised to the power 5 multiplied by, instead of having 4 raised to the power 3, I can have 2 raised to the power 2 in bracket 3. Why? Because 2 raised to the power 2 is the same thing as 4. All over the denominator. Instead of having 8, I can have 2 raised to the power 3 in bracket 2. Why? Because 2 raised to the power 3 is the same thing as 8. Now, I now have 2 raised to the power 5 multiplied by, if I apply a law, I will have 2 raised to the power 6. That is, I'm multiplying the power of power gives me 6. All over 2 raised to the power 6 as well. Now, applying my product law, I can say 2 raised to the power 5 plus 6 divided by 2 raised to the power 6. That is 2 raised to the power 11 over 2 raised to the power 6. So I simply have, using my quotient law, 2 raised to the power 11 minus 6 will simply be equal to 2 raised to the power 5. So I have simply simplified this question into this. Let's try another example. If I have 3x squared y negative 1 raised to the power of 3. Now, I will apply my law 3 raised to the power 3 multiplied by x squared raised to the power of 3 multiplied by y negative 1 raised to the power of 3. So I simply just distributed this raised to the power of 3 for all the factors inside of the brackets. So what do we have? 3 raised to the power of 3 multiplied by x raised to the power of 6 multiplied by y raised to the power of negative 3. So I end up having 3 times 3 times 3, that's 27, times x raised to the power of 6 multiplied by x raised to the power of negative 3. So the solution to that question will just simply be 27 x raised to the power of 6 y raised to the power of negative 3. Practice time. Let's test what we've learned. Try solving this and drop your answer in the comments. That's it for today. I hope the laws of indices are much clearer now. If you found this helpful, don't forget to like, share, and subscribe for more math tips. See you in the next video.